Hello everyone, my name is Jay Aditya. Today's topic about basic logic gates on symbols, truth table and implementation on switching theory and logic gates. If you see, what are logic gates? Logic gates are the fundamental building blocks. Logic gates are the core components of all digit electrons from the sample calculators to supercomputers. Boolean logic operations. They perform basic logic operation on binary inputs 0 and 1 and processing information and produces a lightning speed. In digital circuits found in CPUs, microphones and various digital circuits, embedded and data and decision making. If you see that some basic logic gates are AND gate, the digit all or nothing. The AND gate gives the output when true, it gives 1. All the inputs are 1. If one output is 0, false, the output is 0. Boolean expression for AND gate. Q is equal to A into B. In here, the pictures A into AB are the inputs and Q is the output. Truth table. Two inputs are taken. 2 power n, 2 power 2 equal to 4. Then 4, we will give the 4 inputs, then 4 outputs are 0. A0, B0. Q also 0. A0, 1, 0. A 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. In AND gate, any one of the inputs become 0, output will become 0. Both are 1, output will 1. Typically implemented using two transition conditions for series. OR gate, the digit any will do. OR gate gives the output A is true if any one of the input is 1. Only two outputs are 0, then it will give output is 0. Boolean expression for OR gate, Q equal to A plus B. Here if you see the image, A and B are the inputs and Q is the output. For truth table of OR gate, 0 plus 0 equal to 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. Commonly implemented using diodes connected to the inputs allowed currents to flow if all any inputs is high and a resistance to produce pulling the output. NOT gate. NOT gate is also known as inverter, has only one input and one output. It always output the opposite of its input. If you give the input is 0, then we will get output as 1. If you give input is 1, then we will get output as 0. Boolean expression for NOT gate, Q is equal to minus A. This is the symbol of NOT gate. For truth table, 0, 1, 1, 0. It implements typically involving a single transistors acting as a switching that either connect the output to the ground 0 or the power supply 1 based input voltage level. NAND gate, the universal gate. Here universal gates are two types, NAND gate and NOR gate. NAND gate. The NAND gate functions as a AND gate following by a NOT gate. It outputs 0 and all inputs are 1. Otherwise its output 1. It makes it a universal gate, meaning any other logic gates can be constructed solving using NAND gate. We can construct different types of gates by using universal gate, NAND and NOR gates. Boolean expression for NAND gate, Q is equal to AB complement, A into B complement. These two are the symbols for NAND gate. Here you see OR gate, AND gate and NOT gate are combined to give NAND gate. Truth table, 0, 0, you will get 1, 0, 1, you will get 1, 1, 0, you will get 1, 1, 1, you will get 0. Both inputs are high, then output will low. Any one of the input is low, then output is high in NAND gate. NOR gate, another universal gate. Similarly to NAND, the NOR gate acts as a OR gate as follows at NOT gate. If you give output, it give output 1, only all inputs are 0, otherwise its output 0. Like the NAND gate, the NOR gate is also a universal gate capable of constructing all other logical gates. Boolean expression for NOT gate, NOR gate, Q is equal to A plus B whole complement. Here are the symbols for, if you see OR gate plus NOT gate combines to give NOR gate. Truth table for NOR gate, 0 plus 0, 1, 0 plus 1, 1, 1 plus 0, 0, 1 plus 1, 0. Here you see both inputs are low, then we will get output as high. If any one of the input is high, output is 0. Its circuit Its implement effectively combines the OR operations with an inverted edge stage. XOR gate, the digit either or. The XOR gate outputs 1 if inputs are the different and 0 if the are same. It circuits of arithmetic operations and error detections in digital circuits. For NOT gate is Boolean expression for XOR gate is Q is equal to A plus circle B. Here you see OR gate and a single line truth table for XOR gate 0 0 0 0 1 1 1 0 1 1 1 0. Here OR gate we can see both inputs same, then we will get 0, but different inputs are different, then we will get 1. XNOR gate, the digits are same. The XOR gate gives the inverse of XOR gate. The output is 1 if the input are the same and 0 if they are different. It gives parity checkers and arithmetic logical unit. Boolean expression for XOR gate A dot circle B. This is the symbol for XNOR gate. Truth table for XNOR gate 0 0 1 0 1 0 1 0 0 1 1 1. Here you see both inputs are same, then we will get 1. Both our inputs are different, then we will get 0. Implementation of basic gates with NAND gate. NOT gate for NAND. Connect both input of NAND gate another if the input A to the output is A. See the picture. Both input are connected with A, then gives the output is A bar. If you see one input is A and another input is 1, if you see A bar, in A we will take value for 1, 1 into 1, 1, 1 bar 0, 0 into 1, 0, 0 bar 1. NAND gate. Connect the output of NAND gate to the input of another NAND gate. Confuses as a NOT gate. A NAND B. NAND A NAND B is equal to A and B. If you see here, A, B are inputs of NAND gate gives Y into A NAND B. That implies A into B of NAND gate is the output from the NAND gate. Output as the input of two inputs of another NAND gate gives A into B. OR gate for NAND gate. Connect the two inputs A and B to separate NAND gate, acting as a NOT gate. Then feed their output into a third NAND gate. A NAND A, NAND B NAND B, and A or B. You see here A, B are inputs, OR gate A plus B. That implies one NAND gate gives the both inputs of A and another NAND gate gives the both inputs of B. These two outputs of these two NAND gates is inputs of another NAND gate gives the Y is equal to A plus B. Implementation of basic gates using NOR gate. NOT gate for NOR gate. Connect both inputs of a NOR gate using together. If the input is A, the output is A. See here, the input of NOR gate gives A, both A. It will also gives A. XOR gate. Connect the output of a XNOR gate to the implement of another XNOR gate. Confuses as a NOT gate. A NOT B NOR A NOR B gives A or B. Here see the image. A B are inputs of OR gate gives A plus B, and combine with a NOT gate gives Y equal to A plus B whole bar. That implies A into B whole NOR gate gives Y equal to A plus B. AND gate using NOR. Connect two inputs A and B to the two separate NOR gates acting as NOT gate. Then feed their outputs into the third NOR gate. A NOR A NOR B NOR B gives A and B. See here, for one NOR gate, input is A gives output as A bar, and another NOR gate input is B and gives output as B bar. These two NOR gates outputs is combined to gives the input as one NOR gate gives Y is equal to A into B bar. This type we can use NOR gate and AND gate by preparing any basic logic gates using fundamental universal gates. Summarize and importance. The foundations of the digital ages. Digital system code. Logic gates are the absolute foundation of all digital system processing information at the most fundamental levels. Key of digital design. A deep understanding of their symbols, truth tables, and undearly implementation is essential for anyone diving into digital designs, complex operations. By combining these basic gates, engineers building Soviets digital capable of complex operations for adders to entire CPU like full adders and half adders. Both full adders is on the way. Hands-on exploring. Exploring building circuits yourself, your common integrated circuits like 4081 AND gate, 4071 OR gate, 4011 AND gate, 4001 NOR gate, and 4070 XOR gate. On this way, we can use the logic gates in different types in computers